Welcome to Pod 4 Journal Club, where we break down some of the most exciting new research out there. So, what if I told you that the world's most powerful AIs, the ones that can write poetry and code, often get completely stumped by a simple high school math problem? Today, we're digging into a fantastic paper that tackles this exact challenge. How do you teach an AI to actually reason?
Okay, so let's start right there with that kind of weird question. We have these incredibly powerful AI models that can do some truly amazing things. So what is going on? Why do they so often fail at problems a teenager could solve?
Well, the answer really lies in how these AIs are trained to solve complex, multi-step problems. And it's not about a lack of information. It's a fundamental issue with the learning process itself. See, a lot of these AIs learn through a process called reinforcement learning, or RL for short. You can think of it just like teaching a dog a new trick. When the AI gets the final answer right, boom, it gets a reward. If it gets it wrong, it gets nothing. Seems simple enough, right?
Well, here's the catch. This leads to a huge problem called reward sparsity. Imagine you're learning to play chess, but the only feedback you ever get is at the very end, and it's just, you lost. You have absolutely no idea which of your 50 moves was the bad one. That's what it's like for the AI. Most of its attempts just end in failure, so it never gets the feedback it needs to actually learn how to solve the problem.
So the logical next step seems pretty obvious, doesn't it? If the AI is lost, why not just give it more hints? Point it in the right direction?
And that's exactly what researchers tried. They started feeding the AI more and more guidance. Things like longer parts of the solution or abstract concepts. But it turns out just piling on more information isn't the silver bullet. In fact, it can actually make the AI even more confused.
And what I love about this paper is how they break down this problem. The researchers identified 3 specific key reasons why this more hints approach just falls flat. First, there's something called the critical segment effect. It's kind of like a puzzle. The AI's performance doesn't just improve a little bit with each hint. Instead, it makes this one giant leap when it gets that one perfect clue. And then any hints after that are basically just noise. Not only that, but if you add too many hints, they can start to contradict each other and, well, it's incredibly slow and expensive to create good ones in the first place. So, this is the big realization. The goal isn't just more guidance. The real challenge is finding the absolute minimum amount of guidance that is just sufficient to get the AI unstuck. It's all about quality, not quantity. And this single insight is what led to the brilliant new framework that this paper proposes. They call it KnowRL, and it's all built on this simple but really powerful less is more philosophy. Right, so instead of trying to give the AI an entire textbook chapter, KnowRL's goal is to give it just the one specific formula or the one key concept it needs to solve that problem, and absolutely nothing more. The way they did this was by breaking down every single solution into what they call knowledge points, or KPs. You can think of these as the tiny, atomic building blocks of reasoning, the absolute most fundamental concepts you have to know. But here's where it gets really, really cool. As they started trying to pick out the best KPs, they stumbled onto this bizarre and pretty fascinating paradox. See, just getting rid of the KPs that seemed unhelpful on their own didn't always work out. This graph shows that paradox in action. I mean, you'd think that removing a few unhelpful hints would always be a good thing, right? But look at the data. As they remove more of these supposedly bad KPs, performance can actually take a nosedive. This means that some of these hints, even if they look useless by themselves, are secretly working together in really complex ways. So to solve this puzzle, the researchers came up with an algorithm called Constrained Subset Search, or CSS. And what it does essentially is it smartly sifts through all the possible combinations of hints to find the smallest, most effective team of knowledge points that work together perfectly, avoiding all those negative interactions. Okay, so the theory is fantastic, right? A minimal, smarter way to guide an AI. But does this new philosophy actually work in the real world? Let's get to the results and see what happened. So first off, check out this table. The CSS strategy, that's the one that intelligently picks out just the essential hints. It achieved a higher accuracy than just giving the AI all the hints. And get this, it did it while using less than half the number of knowledge points. That is less is more in action, right there on the numbers. Now, let's see what happens when they actually train a model with this method. This chart compares a model trained with KnowRL against other leading models.
The KnowRL model just dramatically outperforms the others, hitting over 70% average accuracy. And the most incredible part? It did this during tests where it got no hints at all.
And we're not talking about a small improvement here. KnowRL boosted the model's fundamental reasoning ability by over 9.6 percentage points on average compared to its base version. In this field, that is a massive, massive leap forward.
And this chart just visualizes the transformation so beautifully. Look at the blue bar on the far left. Before KnowRL, the base model got 0 correct answers on over 41% of the problems. It was just totally stuck. But after KnowRL training, as you can see in the red, that failure rate plummets to just 13%. The AI has actually learned to reason.
So, okay, this is clearly a huge deal for training AI models. But what does it really mean for the rest of us, for the future?
What this research gives us isn't just a better way to solve math problems. It's a powerful and much more efficient new principle for teaching AI how to handle any kind of complex, multi-step reasoning.
I mean, think about it. This kind of advancement could accelerate breakthroughs everywhere. Imagine an AI that can help discover new scientific principles, or design new medicines, or write incredibly complex software, all because it can reason more like a human expert does, efficiently and logically. And that leaves us with a pretty exciting thought to end on. We've just seen a breakthrough in teaching an AI to think logically. So if this idea of minimal, sufficient guidance is the key, what's the next uniquely human skill that we can unlock in a machine?